Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, IIT-Jam, Jest and other exams related to physical science. Okay, so this is the lecture number 26 of the mathematical physics. Okay, so in which we are going to solve uh, improper integrals. Okay, whose limit is between minus infinity to plus infinity. Okay, in complex analysis. Okay, so also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so we are discussing complex analysis in which we are going to discuss improper integrals whose limit is between minus infinity to plus infinity, how we are going to solve those questions. Okay, so I'll start now. And meanwhile, let me just check whether I'm audible or not. This is very important because many times I get difficulty in audio. There is an issue in audio. Okay, let me just check it. Improper integrals. Whose yeah, yeah, I am audible. Okay, so I'll start now. There is no audio issue, so I'm going to start. So this is improper integrals. Improper integrals improper integrals between the limit minus infinity to plus infinity. Okay, so improper integrals between the limit minus infinity to plus infinity. Okay, well, so this I will explain now. Okay, so I'll make a chart for that. Okay, so if fx, that is function, is polynomial of x. Okay, polynomial of x. Okay, if function is polynomial of x, if function is polynomial of x. Okay, and in that case I will divide it into two parts. Okay, the first is the singular points. We are talking about singular points. Singular points lies doesn't lies. Okay, doesn't lies does not lie uh, on real axis. Okay, on real axis. Okay, so function is polynomial of x, and and uh, that the singular point doesn't lies on the real axis, means it lies on imaginary axis. In that case, uh, I is going to be, integration is going to be 2 pi iota sum of residue minus pi I limit z tends to 0 fz. Okay, this one, z into fz. Okay, z into fz. Okay, this is the value. Now second is if lies, singular point lies on the real axis, so in that case I is going to be pi I. Okay, in real axis pi I, and in imaginary axis this is 2 pi I sigma residue, sum of residue, right? minus pi I, limit z tends to 0, z f z. Okay, this is the this case is for polynomial. Okay, now second case is if fx is function of sin x or cos x, sin x or cos x, sin x or cos x. Okay, so in that case there would be two cases again. The first is the singular points doesn't lies on the real axis, does not lies on real axis. In that case I is going to be 2 pi I sigma residue, means sum of residue. Okay, 2 pi I sigma residue. Now it lies on the real axis. Okay, lies on the real axis. So in that case I is going to be pi I. Okay, pi, if real axis, this is pi I. Okay, real means pi I and imaginary means 2 pi I. Okay, sum of residue. Okay, you can remember like that, means imaginary means 2 pi I and real means pi I. Okay, so this is the one. Right now I'll solve question to clear your all doubts. Okay, as example. So question is, I'm starting the question. Okay, I'll also tell you the trick. So by trick you can easily solve questions. Okay, but I'll solve with proper math. Okay, okay guys. So question is integration minus infinity to plus infinity dx upon 1 plus x square. Okay, this you need to find out. So since fz is given and this is the polynomial of x, right? You can see, so fz is given, that is 1 upon 1 plus z square. Okay, so from here 1 plus z square is going to be 0 and value of z is going to be plus minus iota, right? So this is the real axis. Will for if the integration in this form minus the limit is if limit is in minus infinity to plus infinity. Okay, and integration is a polynomial of x or the function of sin x or cos x, and the limit is minus infinity to plus infinity. So we solve this in this way. Okay, I have told you this procedure. Okay, improper integrals between limit minus infinity to plus infinity. Two cases I have explained: polynomial of x fx and fx is function of sin x cos x. Okay, so we'll take a semicircular axis, right, and this will be minus infinity to plus infinity. Okay, and we'll check the roots. So root are, one root is here plus iota and another root is minus iota here, right? Only this root is lies in the semicircular region, right, within the semicircle. Okay, so we'll write, since plus I lies inside the semicircle, plus I lies inside the semicircle, inside lies this inside the semicircle, right? It is lying inside the semicircle contour. So this is semicircle contour will make which starts with minus infinity to plus infinity. So here we can see I is not in real axis, it is in imaginary axis. So so residue is going to be, well, first we'll find the residue, right? Residue at z equal to iota is going to be this one, 1 upon, so we can use this one upon, this is 1 plus z square, or we can write this one phi x upon psi dash x. Okay, so we can differentiate it. So this is going to be 1 upon psi dash x is going to be 2z at z equal to iota, right? and this value is going to be 1 upon 2 iota. Okay, 1 upon 2 iota, 1 upon 2 iota, 1 upon 2 iota, right? And so this is the now we know the value of integration is going to be, because it is in imaginary axis, right, not in real axis. So this is going to be 2 pi I sigma residue, right? 2 pi I sigma residue, sum of residue, right? So this is 2 pi I into 1 upon 2i. 2i will get cancelled, the value is pi. Okay, so pi is the answer. Next question, guys. Next question is, we have to find the integration minus infinity to plus infinity dx upon x square plus 1 upon x square plus 4. I'll tell you the trick of solving these as well, okay? But before that, I will solve it with proper method, okay? Well, so here we can write minus integration, so this is polynomial of x, right? So minus infinity to plus infinity dz upon z square plus 1 into z square plus 4. Okay, so this is going to be so this one z square plus 1, that denominator will be equal to 0 for poles, so z square plus 4 equal to 0. Okay, so the value of z is going to be plus minus iota and plus minus 2 iota, right? So we'll make a semicircle which goes from minus infinity to plus infinity, right? And we can see I and 2i both lies I and 2 iota both lies within the semicircular contour, and minus iota and minus 2 iota doesn't lie. So we'll just think about this, okay? Consider those. So we'll find residue which lies inside the contour, okay? Semicircle contour. So residue at z equal to iota is going to be simple limit z tends to iota, and this is going to be z minus iota into 1 upon z plus iota and z minus iota. We can write, right, 1 plus z square plus 1 into z square plus 4. Okay, so this value is going to be z minus 1, z minus 1 will get cancelled, we'll put the value. So this is going to be 1 upon z plus 1 means iota plus iota, right? And iota plus iota, and this is going to be iota square plus 4. So this value is going to, iota square is minus 1 3, and iota is 2 iota 6, 1 upon 6 iota, 1 upon 6 iota, right? Similarly, residue at z equal to 2i is going to be limit z tends to 2i, okay, and z minus 2i upon z minus 2i and z plus 2i, z plus 4 we can write like this, okay, on z square minus 1. Okay, so we'll put the value, and this value is going to be that this will get cancelled, and this is going to be 1 upon z value is 2i plus 2 iota into z square is 2 iota square plus 1, right? And this value is going to be minus 1 upon 12i. Okay, so there, and these two lies on the imaginary axis. So iota is going to be 2 pi iota sum of residue, right? This is going to be 2 pi iota into 1 by 6i minus 1 upon 2 pi I. Okay, and this value is going to be pi by 6. pi by 6. Okay, pi by 6. Next one, this question I will tell you by trick as well. Okay, so just next, now I'm going to tell you the trick. Okay, so trick is very important, so you need to know that. Okay, trick is if minus infinity to plus infinity, we have a function that is dz upon z square plus a square into z square plus b square. Okay, so we have any function which is between minus infinity to plus infinity, dz upon z square plus a square into z square plus b square, right? This directly the value is going to be pi by a upon pi upon ab into a plus b, pi by ab into a plus b. So same question, this one we can solve this by trick. So this is this one, x square plus 1 and this z square plus 1 z square plus 4. So okay, so minus infinity to plus infinity, this is dx upon this is x square plus 1 and z square plus 4. We can write z square plus 4 2 square, right? So a square plus b square, dz upon z square plus a square into z square plus b square is going to be pi upon ab. Ab is 2 and 1. This is 1 square, right? Here 2ab means 2 into this is 1 into 2, 1 into 1 into 2 into 1 plus 2 a plus b, right? So this is going to be pi by 6. Very easily we have solved this equation, pi by 6, right? And the same question we have solved it by trick very quickly, right? So minus infinity to plus infinity is dz upon z square plus a square into z square plus b square. That value is pi upon ab a plus b. Okay, similarly this question, the first question which we have solved, this trick, second trick we are going to solve. Second trick is this one. Trick is if minus infinity to plus infinity, okay, and 1 upon 1 plus x to the power n dx. Okay, if we have this this one, so this we can minus infinity to plus infinity, guys. Okay, no, here is different one. So this is 0 to infinity, guys. Okay, 0 to infinity, limit is 1 upon 1 plus x to the power n dx. This value is going to be very simple, that is pi by n cosec pi by n. Okay, pi by n cosec pi by n. So now the question which we have been given, we can easily solve, right? This question was given earlier, that was I have solved by proper method, right? So this is minus infinity to plus infinity, okay, and this is given 1 upon 1 plus x square, right, dx. This we need to find. We have found the value pi. Now I'll solve it by trick. So the limit is minus infinity to plus infinity, x square, x to the power whole square, right? So this is a even function. If it's a even function, right, so we can break the limit. So it is going to be 2 0 to infinity 1 upon 1 plus x square dx, right? So this is going to be by trick 2 into pi by n, means pi by 2 cosec pi by 2, right? And so this is going to 2 will get cancelled, cosec pi by 2, pi into cosec pi by 2 value is 1, so equal to pi, right? So by this we have solved this pi easily, right? This question, right? This question, the value we have found it, right? Its value is pi, right? And by trick, see how quickly we have solved this question. Okay, next question is next question. By this trick we are going to solve. This question is asked in CSIR NET June 2015. Okay, this question is asked here. So this is minus infinity to plus infinity. Question is minus infinity to plus infinity 1 plus 1 plus x to the power 4 dx. Okay, this is the given, right? And options are given. Options are pi by root 2, option B is pi by 2, option C is root 2 pi, and option D is 2 pi, right? So we have to solve it. So very simple, we'll use the trick, right? First we can see minus infinity to plus infinity, 1 upon 1 plus x square dx. We can see this is even function, because x to the power 4 is always going to give a positive value, right? So it's an even function, so it means we can break the limit. So this is going to be 0 to infinity and 1 plus x to the power 4 dx, right? And this value, you know, by trick, 0 to infinity, 1 upon 1 plus x to the power n is pi by n cosec pi by n, right? So pi by 4 cosec pi by 4, right? So this is going to be pi by 4, and 2 is also there, 2 is also there, 2 is also there, right? 2 will to this cancel, this is going to be pi by 2, and cosec 1 by 2 is root 2. So cosec pi by 4 is root 2, and this is going to be pi by root 2, and this is the answer, option A. Okay, pi by root 2, option A is the correct answer, guys. Okay, very simple question asked in 2015 June CSIR net. Next question, guys, a very important one now. So the second case, right? If fz is into fz is a function of sin x or cos x, then how to solve it, right? Here what we can do is e to the power I theta equal to, we know, right, cos theta plus iota sin theta. Okay, cos theta plus iota sin theta, this we know. Okay, this is real part and this is imaginary part. Okay, now for this type of question, what we are going to do, e to the power theta, e to the power theta will put z, e to the power theta equal to z. So this means iota e to the power I theta upon dz upon d theta, we have differentiated with respect to theta. Okay, so this is going to be, that implies value of z is going to be dz upon, my apology, the value of theta is going to, d theta is going to be, value of d theta is going to d theta upon e to the power iota theta, or dz upon iz, because iota e to the power iota theta is iz. And value of cos theta will write 1 upon 2 z plus 1 upon z, this we know, right? Because cos theta is e to the power I theta plus e to the power minus I theta by 2, right? And e to the power I theta is z, it means e to the power minus I theta is 1 upon z. Similarly, sin theta is going to be 1 upon 2i z minus 1 upon z. Okay, this will put, now I'll solve the question. Okay? Question is, we have to solve minus infinity to plus infinity sin mx upon x dx. Okay, and m is greater than 0. Okay, so for solving it, what we are going to do, imaginary part of imaginary part of integration minus infinity to infinity e to the power iota mx upon x dx, right? We can write this because imaginary part is going to be sin theta mx upon m. Okay, so its imaginary part is this value, right? So we can write this. So this means imaginary part of this is going to be integration minus infinity to plus infinity. Okay, e to the power iota mz we can write, right? So mz upon z equal to I, right? So I is going to be now So here you can write fz function is going to be e to the power I mz upon z, right? So polar are going to be z equal to 0, and which lies on real axis, because I have already told the procedure, right? So this is the real axis, semicircular axis, minus infinity to plus infinity, and 0 is here, okay, which is lying in on real axis, right? So real axis means we know that I is going to be very simple. So first we'll find residue at z equal to 0, residue at z equal to 0. So this is going to be limit z tends to 0 e to the power I mz upon z, right? So this is going to be uh, this is z into, right? Z will get cancelled. So e to the power 0, that value is 1. Okay. So I is going to be, value of I is going to be, because it is in real axis, means pi I sigma residue, right? So pi I into 1, that is pi I. This is the answer, guys. Okay. Next point. Next point is, next there is a trick of solving different question. I will tell you how to solve this. Okay. So I'm telling you the tricks. So there are many tricks I have explained today. So you need to note down those tricks. Okay. So trick is function f to be analytic, right? And we know z equal to x plus iota y. For function to be analytic, there are some point which if function satisfies these points, then function will be analytic. Okay, f to be analytic, x, y, these are real part and imaginary part of z, right? Or x comma iy shouldn't be there, shouldn't be in the function. Okay, I'll tell you, I'll solve the question, then it will clear it out. Okay, as of now just write it. Shouldn't be there. Okay, these terms shouldn't be there. Okay, next is power of z, so power should be, beside power should be integral power of polynomial. Okay, integral power of polynomial. So there should be integral power of polynomial. Okay, if power is not integral, it is fractional, then that function will not be analytic. Okay, I'll tell you that as well. So, and since z equal to x plus iota y, right? So z, and also guys here, very important, z bar shouldn't be there. Okay, if there is z bar, there are xy or iy, right? Or powers are fractional, then that function is not going to be the uh, analytic function. Okay, and so since z equal to x plus iy, right? So it means it means z is analytic. Okay, z, if z is there, that is analytic. Okay, z is analytic. I'll solve a question. Okay, then it is going to clear your all doubt. So z is analytic. Z will be analytic. Okay, if Z is there, then that would be analytic. Okay, next point is Z square will also be analytic. Okay, next Z cube will also be analytic. Okay, and power of integral power will be analytic. Okay, and Z square plus 3Z square plus 3Z plus Z, this will be also analytic. Okay, because these are integral power of Z. Okay, now 1 plus, these are tricks guys. Okay, 1 plus Z whole square, this is also analytic. Okay, next, the example I'm giving you, like you need to just check it. Okay, for example, if there is 1 plus x plus z, okay, this is the function. So is it analytic or not? This is not analytic because x is there. I have told you in trick, x shouldn't be there, xy, right? Second example, this is 1 plus x plus 1 plus x plus iy plus z. Okay, this will be analytic because we can write this 1 plus z plus z, right? Or we can write 1 plus 2z. So this is analytic. So there is no z term is there. So this is analytic. Next example, just these are just example. Then we'll solve question. Okay, 1 plus x, 1 plus x, 1 plus iota y, 1 plus iota y plus x. Okay, so this is not analytic guys because iy term is there, right? And 1 minus iota y plus x, this is not analytic. X minus iy is z bar, right? So we can write this like x minus z bar because z bar is equal to x minus iy, right? So if z bar is there, then this is not analytic, right? I have already told you, yeah. Z bar shouldn't be there, right? Next example is 1 plus x minus iy plus z to the power half. This is not analytic guys because this is z bar term and whole power is fractional, so this is not analytic. Next, 1 plus z to the power 1 by 2. Okay, this is also not analytic. Why? And which is not analytic, I'm crossing. Which is analytic, I'm taking the right. Okay, so this is not because the whole power is fractional, not integral. Okay, similarly here z bar is not analytic because z bar is present. Okay, so this is the trick. I give and I also give an example. Now I'm going to solve question, okay, which was asked in CSIR net. Okay, that's why I told you this trick. You can easily solve now. Okay, question is asked in CSIR net June 2012. Okay, June 2012. Question is which of the following, this is the question. Okay, which of the following is an analytic function of z in the domain z less equal to 2. So which of the following is an analytic function in the domain z less equal to 2? Okay, options are given: 3 plus x minus iy to the power 7. B is x plus iy minus 1 to the power 7. C is 1 plus x plus iy to the power 4 into 7 minus x minus iy to the power 3. Okay, option C. Option D is 1 plus 2x minus iota y to the power 4 into 3 minus x minus iota to the power 3. Okay, so this is the one, guys. Okay, we have to check which function is analytic. Okay, option B is 1 minus iy. This is 1 minus iy. Okay, so this is the question. So you can see here, okay, here you can see x minus iy means z bar is there. So this is not analytic. I have already told you to take. Here you can see b in b. So x minus iy, z bar is here. So this is also not analytic function. This check this. So x plus iy is z bar. So we can write like 1 plus z to the power 4, x plus iy is z, right? Minus and 7 minus will common, right? If you take minus common, then this is going to be x plus iy, and that is z, right? So minus z to the power 3. So this is analytic function, right? There is no z bar term, there is no xy term, right? And there is no fractional power. So this is the analytic, and if you check here, so this is x 2x minus iy, right? So this is 2x is also there, iy is also there, right? So if x minus iy is z bar, so this is not the function, and similarly this is also not the function because here z bar is present, right? So this is not the analytic function. So option C is the correct option, right? Right, guys. Okay, next it is a question which is asked in June 2012 NET question. Okay, question is CSIR NET CSIR NET CSIR NET June 2012. Okay, question is integration minus infinity to plus infinity 1 upon t square minus r square cos pi t upon 2r dt. Okay, this is the question. Options are minus 2 pi upon r. Option B is minus pi upon r. Option C is pi upon r, and option D is 2 pi upon r. Okay, so this is the question. Very good question. We are going to solve it. Okay, and it is asked in CSIR NET June 2012. Okay, minus infinity to plus infinity into t square 1 upon t square minus r square cos pi t upon 2r dt. Okay, so I'm going to solve it. So I is going to be integration minus infinity to plus infinity 1 upon t square minus r square cos pi t upon 2r dt. Okay, so we can write this like this: I equal to real part of integration minus infinity to plus infinity 1 upon t square minus r square e to the power iota pi t upon 2r. We can write it right, dt, because real part of this is this function. Okay, well, or we can write fz equal to real part of 1 upon z square minus r square e to the power iota pi z upon 2r, right? So now we'll find the pole for r square z square minus r square equal to 0 implies z equal to plus minus r. Okay, and here we can see this is the one, right, semicircle, and we can see the plus r and minus r lies on real axis. Okay, real axis, right? So both lies, so it means we'll find the residue. So residue is going to be residue at z equal to r. Residue at z equal to r, this is going to be e to the power iota pi z upon 2r upon 2z. Okay, what we have done is this. So we have used this function, this phi x upon, forgetting limit, phi x upon phi dash x at z equal to r, right? So this is at z equal to r. So phi x will remain as it is, right? So now we'll put the value. So this is going to be e to the power I pi by 2 upon 2r. Okay, and now we know, I'll tell you the thing, you should note down. Okay, value of I is e to the power iota pi by 2. This value is I, or e to the power and iota pi by 2 value is 1. Okay, or e to the power, that's a different thing. Okay, as of now just note down this. E to the power iota pi by 2 is 1, and similarly minus iota is e to the power minus iota pi by 2. Okay, and also e to the power iota pi value is minus 1. Okay, and e to the power iota 2 pi value is 1. These you should know. Okay, now so this value is iota, so we can write iota upon 2r. Okay, now next, residue at z equal to minus r. Again similar way, so e to the power iota pi by iota pi z upon 2r upon 2z at z equal to minus r. So this value is going to be e to the power minus iota pi by 2 upon 2r, because z will put minus r, right? R will get cancelled, 2r. So this is going to be minus iota upon 2r. Minus iota upon 2r, because r equal to minus 1, right? Minus will get cancelled, so iota upon 2r. It is on real axis, then I is going to be pi is going to be pi I, right, real part of, because this is the real part, right? Real part of pi I sigma residue, right? So this is going to be real part of pi I into sigma residue, means I upon 2r plus I upon 2r. Okay, so this value is going to be iota minus iota, right? This is iota square, and this is 2 will get cancelled, so this is going to be minus pi r. So this is the real part, so answer is minus pi by r. So which option is matching? Option B, minus pi by r. Okay, this is the value, guys, minus pi by r. Okay guys, so now complex analysis is completed, guys. So in next class we are going to discuss Fourier series. Okay, well, okay. So guys, okay, so guys,